So I'm going to talk about one of my favorite topics, which is basically generative AI and how can we use generative AI for graphic design apps and website building. So I'm going to start just by a quick overview in case people don't know what Wix is. So Wix is basically a platform that allows people to build and customize their websites without using code. So the most popular thing we provide to people is what we call the Editor 2.0, which is basically a drag and drop website builder where you have the visual experience of taking components, placing them, customizing them, and then you can build really the design that you want. And we also provide you with a great starting point through a variety of templates. So let's talk a little bit about the generative AI revolution, and let's start with this. So let's start with showing this kind of this timeline. So I think that generative AI became really well known to the public with the launch of ChatGPT. So this happened a couple of months ago. In case people don't know, ChatGPT is basically a robot that you can talk to. You just log in and start to have a conversation with it. And we see these kind of big leaps happening in AI once in every few years. So the previous time we had this was, I think, around 2012 with the emergence of deep learning. And by the way, a lot of companies, once they see that AI is picking up, started to build technologies around AI, and Wix is not different. We actually set up the data science team in Wix around 6-7 years ago, and we released our first products were what we call ADI, which uses a really early version of generative AI to build websites. And this thing called ADI is actually a website builder where we ask the user a few questions. We take that plus some other information we know about the user, and the system automatically builds you a website. And I've been doing a lot of really cool things with AI in the last few years, but I'm going to basically talk about generative AI. So that's things that are happening like in the recent year. So I want to start with this kind of, this really cool demo that went viral, I think, a couple of months ago. And here what we can see in this demo is that somebody sketched a design of a website on a paper, used ChatGPT to convert that into HTML code, and to get a website, okay? So I think this basically raises the question, what does that mean for traditional website building platforms, such as Wix? And to me, the most inspiring part about this demo is actually the ability of the AI to do the OCR, to take that written text and translate it into machine text, right? Because if you really look at what's happening here, you got a landing page rather than a fully functional website. And a fully functional website actually consists of a lot of business logic, right? It allows you to do SEO, it allows you to maintain mailing lists. What about editing your website once you're done creating it? How do you do this? And the other part that is really interesting here is that you can see the layout or the design that you got. It doesn't look that it doesn't look that modern, right? The layout is pretty limited. So I guess this begs the question, really, if you want to use generative AI to build a website, how should you do that, right? So just a quick refresher on what is generative AI. So generative AI is basically a set of machine learning algorithms that basically this set of algorithms allows that basically are able to generate human-like content, okay? So for example, the user can provide a description of what they want. They usually can do it through a prompt, so create a website for a running shoe, or they can give you some sample of the content that they want. And the generative AI, the machine learning algorithm, generates a new realistic sample, okay? So you get this website. And I think the most known so generative AI can be used for a lot of things, but the most known model is what we call the large language model. And this is ChatGPT. So, by the way, GPT stands for Generative Pre-trained Transformer. Okay, so generative means that it can generate text. So So you input some text in natural language, right? I want to plan a trip to Canadian Rockies, and the model just gives you an answer in text. Pre-trained means that it was trained on huge amounts of data, right? Actually, the GPT-4 or 3.5 was trained on a significant chunk of the text available in the internet. And by the way, the model is called large language model, not only because it was trained on a lot of data, but also because it has a lot of parameters, so a lot of computational units, which gives it the power to really understand the relationships, the relationship we have in our language and the patterns that we have in our language, and basically kind of get some sense of understanding of the world by going over these texts. Okay, and the T in GPT stands for transformers. So transformers, the type of neural net that enables these kind of generative AI models. And this is one of the biggest achievements in, I think, in terms of deep learning architecture. So this is the most dominant architecture in the last few years, and it's really an enabling technology for building these kind of generative AI. So let's talk a little bit about the problem of, let's use AI, let's use generative AI tools to build a society. So some people want just to sketch, right, and turn that into a site, but the more common workflow is that we kind of go to the user and ask him, hey, what's your intent? Why do you want to build this website? What kind of business do you have? What kind of visuals do you want to have in your website? What kind of tone do you want us to use? And you let the AI build for you a few alternatives, and the user select them, right? And so before we want to talk about how can we use AI to do this wonderful process, let's think a little bit about how we as people do this, right? So people typically use kind of three essential elements for web design, right? So the first one is layout and structure. So this is the part where we think about how to position. So what's the spatial arrangement? How do we position the different content elements that we have on the canvas or on the page? The other part is the content itself. So these are the text, the images, the videos, the things that actually deliver the information, the messaging that we want to our users. And we also have the style. So this can be something like the fonts that we have, the coloring scheme, the styling elements we use. And if we combine these three elements together, right, if we do it right, what we can get is a good-looking website that allows the users to easily interact with it and also delivers the message that the owner of the website cares about, right? Any questions so far? Cool. So let's talk about how can we do this with AI. So, and by the way, what I'm showing now is just one approach. There are multiple approaches. This whole field of how to basically generate multimodality documents. So these are documents that have different kinds of content, like images, text, videos, etc. This is a field that is being researched now. So, and we see a lot of innovation and a lot of changes. So, things can change, but this is kind of one approach to doing things. So the heart or the brain behind such a system can be your ChatGPT or your large language model. And here you actually need to have a really good, a really sophisticated large language model. So the large language model gets a query that says, I don't know, build me a website for, for a dog walker in Tel Aviv. And then the ChatGPT builds an outline out of this. And it's also connected to these services through APIs. And it can interact with those. And the way to think about it is these services are kind of experts that help ChatGPT to solve this task. And it can interact with them and take the answers from each one of them and compose them and merge them together so we can get a working website. And these kind of services can be content creation, can be image generation, can be layout generation, can be style generation, and even can be this stitching, this merging service that takes all that information and merges it together. Okay. So now we're going to talk a little bit about image and text generation, which is kind of a crucial part of building such a system. So, so one of the big challenges that our users have is basically writing content for the website. A lot of the times they start writing content, but they're not sure how to continue and they get stuck. So what made a lot of sense to us is actually to give them as part of our website building platform, to give them an integrated writing assistant based on ChatGPT. Okay, and here what we do is we basically ask the user for their business name, business type, few keywords like what is unique about your business, and we use ChatGPT to generate the text for them. And this was really great and really helped our users to complete their websites, and we've seen a lot of engagement with this feature. And some people might think, okay, you know, what's so hard about this? Like, OpenAI solved you the problem, right? They gave you these APIs, just use them, everything works. But in fact, we actually had to do a little bit of work to make sure that we kind of tune ChatGPT to our specific use case. And the way I think, if I want to kind of describe the journey that we had of tuning ChatGPT to our specific use case, looks like this, right? So this is a common graph. It's called the Dunning-Kruger effect, where basically, you know, there's this trade-off between your expertise and how confident you are. So initially, you put in some simple prompt, you feel really confident, it's going to work, not a problem, and you're at peak of Mount Stupid, right? Then you start to validate this thing, and users tell you what they actually, and you see how users are using it, and you get feedback from users. And then you kind of start to understand that maybe you're not as big of an expert as you thought, and you need to iterate more. And as you iterate more, you understand, oh, this would require much more work, and you're kind of at what they call the valley of despair, right? And at that point, please don't give up. Try to think about the problem and try various techniques, and suddenly you can start to see what they call the slope of enlightenment till you kind of get to the plateau of sustainability. Okay, so let's show this process. And by the way, this happens a lot when you're building such a thing for the first time, right? Like, first time that you're building such a feature, you kind of go through that. The second time, people just expect you to get it out really fast to production. You're supposed to know what you're doing. So we start with the basic prompt, right? We write 2 lines, write me a paragraph about specific, whatever the user decided as the business, beautician called skin transformation, and you get this result, right? Looks pretty great. Actually, if you write such a prompt, works for a lot of the cases. And then you start to evaluate it. And then you realize, okay, what happens about the remaining 20, 30% of the cases, right? These are also customers that want to use this feature. So you immediately see the issues of controllability that large language models have, right? It's pretty hard to control them, especially if you want to get these kind of consistent results. So one thing is like, okay, if I just want to limit, so I know that this whole output, or I know that the text that I want to generate should fit within 2 sentences. How do I tell GPT to do that? So if I just tell him, you know, write this up to 2 sentences, lots of the time it doesn't work. And the other thing is that there is this really interesting trade-off that happens here, especially when you want to generate multiple results. So generating one result that is of high quality, that's relatively easy. Generating multiple results, each one of them of low quality, that is also multiple diverse results, so each one is a little bit different, but all of them of low quality, that's also not such a hard task, right? There is like something called temperature within the OpenAI. So this is a parameter that tells OpenAI how much randomness are you willing to sustain within your answers, and ChatGPT ChatGPT can actually generate somewhat random answers. In AI world, they call it hallucinations. Some people just can call it just plain lies, right? So, but I think But I think the main issue is if I want to generate multiple responses, each one of them of high quality, but each one of them is different from the previous one, that's not such an easy task. And there's also like the actual kind of the interaction between the user experience and the use case that you have. So for example, if I want to build a website for a business versus a website for myself as a person, I would like to use kind of a different way of describing what we do, or basically the tone of voice that I'm going to use. It's going to be first person versus third person tones, right? So then you start, like you're here at the valley of despair, and you start to iterate, and hopefully you have a really great data science team, or you have access to really great data scientists that can help you. And you start to iterate on that. And then at the end, remember, we started with a 2-line prompt. And this is the actual prompt that tries to solve all of these problems, right? So we now have a huge prompt. So one thing that you can do is you can do something called few shot. So you can include an example of the desired output that you would like to have as part of your prompt, as part of your input, right? So this really helps with managing the length of the, so this helps you to control the length of the desired output. And actually, if you put in just multiple examples, and each one of them has different way of writing, different way of tone, different way of styling, you can actually get these, the right working point. So you get 3 results. All of them are high quality, but different enough from one another. And you can also write specific instructions, so to deal basically with the issue, is this a website for a person or a business, right? And then there's the small thing that now your cost increased 10 times or 20 times, right? And you have to deal with that. So, but that's another story. All right, so, and I think this whole world of, it's called prompt engineering, right? So basically, how to take large language models and tune them using the prompt to get you the desired results. So there are a lot of best practices on how to do that. I'll try to summarize some of the things we saw from our experiments. So one thing, like I said before, start simple, do evaluation as fast as you can, not only on typical cases, but also on corner cases, and try to map the issues, right? This is the classical kind of data science methodology. Then, many times, don't generate just one result. So we, in our case, really needed to generate 3, but internally with ChatGPT, we could have generated, let's say, 5, and pick the best 3 for the user, right? So this is a common, common practice that people use. They generate more results than they actually need and pick the best ones. And now you can actually. That's an amazing question. How do you know which answer is best? So first of all, you can do some. Yeah. So first of all, So you can. So he already gave you the answer, but you can build some model that does majority vote. You can let the users choose, or you can let GPT pick for you, and that's actually what works best. But this is a little bit expensive, so you kind of have the trade-offs for using these.
What's the difference between the first option and the last one? Like building a model that chooses and using ChatGPT?
Because you're kind of using the same model versus building another model that might have been trained on specific data, where this one was general and trained on generic data. Yeah. I think the main thing with GPT is that you can experiment it with really fast, right? But that's a really great point. The other thing I can say is that if you have a really complex task, sometimes it's pretty useful to take this prompt and break it down into smaller ones. So it's much easier for GPT, sometimes like humans, to solve small tasks and combine them together rather than just a big task. And then there's also another common pattern that people use is you can actually ask the model to explain how did you get to that particular answer, right? So, for example, in the case of the agent we talked about, right, you can ask this ChatGPT, why did you apply the layout selection, or why did you apply the image generation in this particular way? And the model would explain it to you, and this allows you basically to to debug things and understand what are the decisions, the internal decisions that the large language model is making. And this is called chain of thought, and this is something very interesting. If you're not familiar with, go check it out. Okay, so we talked a little bit about text generation. What about image generation? So for image generation, we already have many tools, right? So we have DALL-E, we have Midjourney, we have many other tools. And basically here you apply the same idea. You do prompt engineering. So you write some text, right? You write this text, and then you get these kind of results. In practice, it seems like image generation is a little bit behind text generation in terms of readiness for production, I would say. So it's actually much harder to, not much harder, but it's harder to tune the prompts and harder to tune the kind of the process is a little bit harder in terms of the prompt engineering compared to text, right? So, and I'll try to demonstrate this using this kind of simple example. So imagine you want to generate multiple images for your web page or for your graphic design app, right? And you want to generate a collection. So you want all of them to have the same look and feel. How do you do that, right? So one thing, again, you can do is prompt engineering. Oh, what an amazing tool we have. So you can actually write in text, right, for all the images that you're going to generate, what kind of colors would they use, what is the vibe, what is the atmosphere, and really hope that the model will do that, right? And sometimes it does, sometimes it doesn't. The other thing you can do is actually you can condition image generation on another image, right? And this is called outpainting, for example. So here you take this image, you cut a small portion of it, and you generate a new image conditioned on this patch that you cut. And that's what you're getting. So you're basically extending the original image that you have to this thing. And you can actually do something, and you can actually do this also conditioning on a patch. So I can pick this area and tell it, please generate me something totally different, but I want it to have the same vibe as this area, and this is what you get. Okay, so this is another technique that you can use, and there's a third technique called personalization and style transfer that unfortunately I don't have the time to talk about.
This is not part of GTP4.
Correct. This is not, and I'm going to talk about it in the next 2 slides. Okay. Yeah. By the way, any questions so far? Okay.
Yes.
Sure.
About prompt engineering.
Yeah.
I have 2 questions. So first is, who's the persona? Who's the stakeholder that's responsible for engineering the prompt? And how do you track prompt engineering experiments?
Okay, so I'm just going to repeat the questions. So the first question is a very interesting one, and we actually think about it a lot. Like, who's the stakeholder? Who's the persona? What kind of skills do you need to have to do the prompt engineering? So I think it really varies. I would say that it can be different things depending on the skill level that you have. And I'll tell you my own personal opinion, which might be a little bit contrived, is that I think prompt engineering is going to go away soon. So my own personal opinion.
Is for APIs?
No. So for simple things, the models will become so good that they will really understand, they will really learn, and they will understand to give you the exact answers without people doing a lot of hard work on the prompts, okay? But this is only for basic tasks. For the more sophisticated ones, you'll still need to do various flavors of prompt engineering, prompt tuning, prefix tuning, and things like that. So in our case, by the way, I'll tell you what happens in Wix. And so we're typically having so in Wix we have a data curation team. So this is a team that owns data, owns the quality of data, and they're the people that are doing the QA and benchmarking of data. So they, together with the data scientist, are the owners of basically the prompts.
So like the data curation probably responsible for feeding the vector database?
For basically building the prompts, for building the prompts, for building the evals, for building the test sets, and checking.
Engineers or data scientists?
So this is someone that has domain knowledge, and domain knowledge and understanding of the and understanding of kind of prompt engineering in general. So in our case, these are not engineers. These are data curators. These are actually the data curators.
Person, like, is that an analyst? Is that a scientist? Like 2-degree, PhD? Like
No, so you don't need a PhD. It can be done by a lot of people, right? It can be done by a lot of people. Sometimes engineers do that. Sometimes data scientists do that. We have people that are really good at data. That's what they do. They own the data. And in some sense, we're lucky that we have these people because they already understand the domain, they understand the data, and they can help us with prompt engineers. But I assume in other places, you can see the whole spectrum of people doing prompt engineering. Regarding the infrastructure for prompt versioning and all of that stuff, I think this is a great question. I think there are a lot of companies now building all these startups that are thinking about how to build these kind of solutions. In essence, you need to do prompt versioning, like you version anything.
Do you have a way right now to track it, or is that like a gut feel or Excel? Like super interesting.
Okay, so the question is, I would say, how do you track? So I guess the question is, so you have something in production, right? And now you want to change the prompt, the model has changed. How do you track all those changes? So unfortunately, I think we're still in the world of A/B testing. So that's simple. You just test and see if it works. But we definitely have thoughts on how to do this more systematically and in using machine learning or data science methodologies.
Good.
Sure. Okay, so we talked about text generation, we talked about image generation, and let's talk about layout generation. Okay. So why can't we just use these models that are trained to generate images for layout generation? What can be so hard about it? So before we answer that question, let's talk a little bit about the underlying tech for image generation. So what we typically use for image generation is something called diffusion models. And these models are essentially it's noise reduction models. So there is this step that you'd repeat many, many, many times, and that's how you get to the answer. So you take an image that is already noisy, and you apply a machine learning algorithm, some diffusion algorithm, to remove a little bit of the noise, right? And then you take the generated image that has a little bit less of noise, and you remove more noise out of it. You repeat that a lot of times, and what shows up at the end is actually a great-looking image, a realistic image. And what I've shown you here is what we call unconditional generation. So basically, we start with noise, and we get some random data sample. So if we trained our diffusion model on images of flowers, we'll get some random image of a flower. But in practice, what we really want to do is conditional generation, right? We want to condition the generation, we want to guide the generation to basically direct it in some way, and we typically do that with text. So for example, we can say to the model, please generate me something that is a flower, or generate me something that is a person, or a person holding a flower. And we add this conditioning to this diffusion model, and that's what directs the model to generate the right result. And just 2 words about how we train such models. So we take a good image, we add some noise to it. So now we have these pairs of good image and a noisy image. And what we teach the model is how to go back from the noisy image to the good image. So we create a lot of pairs like that. We add various levels of noise. And we just teach the machine to go back and remove the noise and get back to this. And again, we do it in multiple steps. So cool. So following your question, why can't we use this technology to generate layouts, right? So first of all, if you try to use it, you immediately see that these models by nature have, they're diffusion models, right? They have this element of randomness. So it's really unpredictable what you get, right? So these are 2 examples of website layouts that I generated using this prompt. The other thing is that you have really limited controllability, right? Like, how do you specify that I want to have in my layout this button of specific style, right? Or how do I specify design aesthetics? Like I want to have a specific padding, margins, alignment, etc. Right? Doing all of that in natural language seems really weird. And then I think people, if you want to add the layout that you got, it's actually an image. So you need to add it at the level of pixels. But us as designers or as people that are building layouts, we really want to work at component level. So this is probably not the best way of doing things. So before we talk about layout generation, let's talk a little bit about what we call layout understanding. And if you actually want to build models that generate you layouts, you first of all need to understand how are people building layouts, what is happening in practice. And for this, we worked in the last couple of years of this technology called layout understanding. So basically, you can take a look at a web page and ask the AI, is this text the title? Is this image a background? Or maybe it's the main product? Are these two components associated together? And this is really useful because it allows us to understand the visual structure of the page. It allows us to understand the semantics, and we can apply it for various applications. So one thing that we can do with this is actually a feature which we call switch layout. It doesn't use layout generation, just layout recommendation, but it still gives you a similar effect. So here, one of the things that people struggle with is basically building the design of a website, so making their website look great. So people start with a really great template, and then they start to move components around, edit things, change things, and suddenly their design doesn't look that great. So with a click of a button, right, you can get multiple alternatives, and you choose that one, and your website looks great again. And what happens here under the scene is that you're using this layout understanding technology to figure out the visual intent of the user, and with that you can offer relevant designs that improve the actual design that the user has. Okay, so, and not necessarily generation here, you can just pick from a pre-ready templates that you have, and that is good enough as a starting point. Okay, so let's talk a little bit about layout generation. So this is yet a not solved problem, and this is a problem that the research community is looking at. And since this is a challenging problem, one of the things that the research community likes to do is to simplify the problem. So basically, they're looking at the problem of generating a wireframe of a layout, right? So what we want to get is this thing. And you control this generation at the component level, right? So you can specify the types of components you want to have, and you can specify their initial placement and sizing, or you can let the model choose, and the layout generation model generates you this. So let's make it a little bit more concrete. So let's look at this state-of-the-art layout transformer. Again, we're seeing the word transformer. So you can think about it as like a custom large language model that is designed to generate layouts, right? So this model accepts as an input a very specific prompt, okay? It's the component, it's its type, location, and size, and for every component we have, we repeat this thing. So this is the prompt that we accept here. So let's go through a specific example. So let's say we want to generate something that includes an icon, text, and a button. So we can specify that we have an icon, and we already know its Y position, and we know its size. So the only thing the model needs to determine is its X position, so horizontally where to locate this icon. We also want to generate a text component, right? And here we specify the location of the text component, but we don't specify the size. And we also want to generate a button. We specify the size of the button, but we don't specify the location. And the model goes, generate this thing, and then actually takes the content and injects it, so you get this thing. And here you can see the difference between layout generation and regular large language models, right? With GPT, we give it some input, and it always completes that input, right? Here we have something that is called a bidirectional transformer. So basically, we give it an input, and it doesn't only complete past that input, it actually changes things within the input that we give it, okay? And one thing that I want to show is a recent research that my team did on exactly this problem, okay? So our intuition was that while it seems kind of, so you know, the one thing that this system does is actually it uses kind of all of these things should be discrete because all these input, everything should be discrete because this is still a language model. And our intuition was that that may limit the performance of the model because we, like, when we're actually generating a layout, the position, right, and the sizing of elements is not a discrete variable, right? It's actually something that is continuous, whereas the discrete variable that we have is whether do we want to put the type of component we want to generate, whether it's a title, figure, list, or text, right? So, and the other thing we thought of is that if we use the diffusion model to generate layouts, it actually it's much closer to the way a diffusion model, it's much closer to the way a designer works, right? So a designer basically starts with putting a rough idea, so something rough layout, and then it does multiple iterations, fixing things, correcting things, till you get to the right layout to do. And we actually have shown how you can take a diffusion model, so the one used for images, and apply it on layouts. So we actually had to change or build a new diffusion process. And this is how it looks like. And by the way, our results outperforms kind of the other state-of-the-art results. And basically, you start with something that you don't know, right? You're saying, I don't know, I want to have 1, 2, 3, 4, 5, 6 components. I don't even know their types, right? And the system starts to work, right? And as part of the generation process, after a few steps, we kind of said, okay, this should be the title, this should be the figure, this should be the text. Then at the end, we figure out, okay, this should be the title, the figure, the list, text, and actually this is their position and sizing that we need to do, and then you get this thing. So I hope that I convinced you that there are multiple ways to generate layouts, and it's still a researchy problem. So just to wrap up, we talked about this agent approach for AI site creation, where when a user comes in, has a query, build me a website, the ChatGPT generates the structure of the website, then it could go to the style generation, it can go to the layout generation or selection, it can go to the image generation, get all of these pieces of information. The last API can take all these pieces, combine them together, and then we get the final result, which looks like this. And the final thought I have on this is kind of, I try to put down all the basic building blocks that generative AI provides for graphic design applications and for website building. And the upper part is those things that you can actually take for production. So these text generator, text generation, text refinement, image generation, and also in-painting and out-painting are almost ready for production. These things are really cool things that people are working on. They're still not there yet. Like, for example, how do you generate a page, or how do you build custom elements using ChatGPT? That's not clear. But I think the part about text and media, these are things that the first wave of innovation based on generative AI is already using. All right, so just to sum up, AI can really, basically AI and specifically Gen AI-based tools can really enhance the process of building websites and graphic design applications. Gen AI is not only an opportunity, but also a big challenge. And I think what we have seen so far is just the first wave of innovation. And we're going to see many more new products and new technologies, new innovative technologies coming up soon. Thank you. Oh, and by the way, we're hiring. Thank you.